This is a continuing lecture about the fundamental integration formulas. We recall that for the generalized power formula, the integral of u to the n du equal to u to the n plus 1 over n plus 1 plus c is true only for any n except negative 1. So we ask, what will be the integral if n is equal to negative 1? Alright, for n equal to negative 1, the integral will yield the natural logarithmic function. So the integral of u to the negative 1 du, or the integral of 1 over u du, is equal to the natural logarithm of the absolute value of u plus c. Take note that if we get the differential of ln u plus c, we will be getting du all over u. Let us have some examples. So let us evaluate the integral of 4 over y dy. This is equal to 4 integral of dy over y equal to 4 ln of the absolute value of y plus c. Now, we can write our answer as ln of y raised to 4 plus c. One of the properties of the ln function is that the ln of the product, or rather the ln of the power m raised to r, is equal to r ln m. So 4 being the coefficient of ln y becomes the power of y. Hence, 4 ln y is equal to ln of y raised to 4 plus c. Next, we evaluate the integral of 3 over 2x plus 5 dx. This is equal to 3 integral of dx all over 2x plus 5. Now we can take on 2x plus 5 as our u, and its differential du is equal to 2 dx. So we need 2 as coefficient of dx in order to complete our du. So we shall introduce 2 inside the integral and multiply it by 1/2 so that it becomes 1. No? 2 over 2 after all is 1, and we are doing this in order to complete our du. So now our answer will be 3/2. This will be of the form du all over u. Hence our answer will be ln of the absolute value of 2x plus 5 plus c. Next, the integral of 3t minus 2 over t minus 1 dt. Observe that our integrand is an improper rational function because the degree of the numerator is the same as that of the denominator. So what we normally and usually do is we divide the numerator 3t minus 2 by the denominator t minus 1. So this will be 3, then 3 multiplied to t minus 1 will give us 3t minus 3. Then we subtract, so 3t minus 3t is 0. Negative 2 minus negative 3 becomes negative 2 plus 3, or 1. So our remainder is 1. So we write now our integral as 3, the quotient, plus the remainder 1 all over t minus 1 everything dt. So we evaluate 3 dt, which is equal to 3t, plus the integral of dt over t minus 1. That will be of the form du all over u, which is equal to the natural logarithm of the absolute value of t minus 1 plus c. Let us take on some more examples. the integral of y squared minus 9 all over y minus 3 dy. Do not be tempted to factor this as y minus 3 times y minus 3 over y minus 3 and cancelling y minus 3. This is a common mistake of some students. Now, the correct factors of y squared minus 9 are y minus 3 and y plus 3. So let us write that equal to y plus 3 times y minus 3 all over y minus 3 dy. So we cancel y minus 3. So thus leaving y plus 3 as our sole integrand. And we integrate y plus 3, which is y squared over 2 plus 3y plus c, or you may treat this y plus 3 as your u with the power 1. So we can write that as y plus 3 squared all over 2 plus c. Okay, next. The integral of sine 2x over 1 plus cosine squared x dx. Let u be equal to 1 plus cosine squared x. We get the differential du. Differential of 1 is 0. The differential of cosine squared x is, we apply the power formula to cosine squared. It becomes 2 cosine x. Now, subtracting 1 from 2, it becomes 1. But then, we still have to multiply it by the derivative or the differential of cosine x, which is negative sine x dx, which is equal to negative 2 sine x cosine x dx. So this is what we need for our du. But what we have in our integral is sine 2x. Recall that sine 2x is equal to 2 sine x cosine x all over 1 plus cosine squared x dx. So this thing here is equivalent to the negative of du. Alright? 2 sine x cosine x dx is negative du. So we shall write this now as negative du all over 1 plus cosine squared x is your u. That leads us to negative ln absolute value of u plus c. And we know that u is 1 plus cosine squared x plus c. There's no need of writing the absolute value because 1 plus cosine squared x is always greater than 0. We only impose the absolute value sign if the function inside is less than 0. Or we are not sure whether f of x is greater than or less than 0. That is why we impose the absolute value sign. So in this case, it will simply be 1 plus cosine squared x without the absolute value because it is always positive. So that will be our final answer. Next, we integrate 1 over x ln x dx. The denominator is x ln x. So if we are to take the entire x ln x as our u, du will be, well, we have to apply the product rule. Derivative of x is 1 ln x plus x, derivative of ln x is 1 over x, becomes 1 quantity dx. So we need this term, ln x plus 1, as coefficient of dx for our du. And it seems that it is clear, rather, that we cannot find this in our integrand. So we need to check and get another u. And at this point, we take on just ln x as our u. And du is 1 over x dx or dx over x. So we can write our integral as 1 over ln x dx over x. So let me write this as, yes, dx all over x. So this one is du, ln x is our u. So the integral of du over u is the ln of the absolute value of u, which is ln of x, plus the constant c. Finally, we solve the integral of 1 over square root of x plus x dx. So we examine our denominator. Square root of x plus x, taking on the denominator as u, well, you will be getting a differential that is a little bit complicated. It will be 1 over 2 square root of x plus 1 quantity dx. And that expression is nowhere to be found in our integrand. But square root of x and x can be written in terms of square root of x plus square root of x square root of x. All right? In that way, we can factor square root of x. So let us do just that. We write this as dx over square root of x plus square root of x square root of x. Factoring square root of x, we have square root of x times 1 plus square root of x. Take note now that if we use 1 plus square root of x, we will be getting the differential 1 over 2 square root of x dx. Alright? And we have the expression dx over square root of x. It only lacks the constant 1/2. So let us write this now as the integral of dx over square root of x over 1 plus square root of x. And we introduce 1/2. Alright? Now, introducing 1/2 will change our integrand, so let us multiply it by its reciprocal, which is 2. So what do we have now? This is our du, while the denominator here is our u. So the answer then is 2 ln of the denominator 1 plus square root of x plus c. In a nicer form, this is equivalent to ln of the quantity 1 plus square root of x quantity squared plus c. You can now work on the following exercises. I hope you have learned something from my presentation. Thank you for listening.